I want you to imagine, just for a second, that you're out at your job and you accidentally drop a massive glass jar of coins on the ground.
Oh, man.
Right, it just shatters. And those coins scatter absolutely everywhere. They're rolling into the dirt, they're hiding in the grass, falling into cracks.
Sounds like a nightmare.
It really is. Now, imagine those coins are so incredibly valuable to your livelihood, to your farm, that you absolutely have to pick them up. Every single one. But you can't use a broom. You have to do these deep, agonizing squats, bending all the way over and picking them up one by one with your bare hands.
Yeah, your back would just give out.
Exactly. And you don't just do this once. You do this every single day for hours on end in the sweltering heat. It wouldn't take long for that to completely break your body down.
No, I mean, the human spine simply isn't engineered for that kind of repetitive loaded flexion, especially not on uneven terrain.
Exactly. And I want to let you know that the key takeaway for how to actually solve this, the actual blueprint for how you can use a brilliant hack on your farm, comes near the very end of today's discussion. So you're definitely going to want to stick around to listen to that.
Absolutely.
Welcome to another podcast episode brought to you by AGS Agriculture Global Solutions, where we discuss sustainable oil palm cultivation topics. Today, we're doing a deep dive into a really fascinating paper.
Yeah, it's a great one.
It is. It's a December 2025 research paper from the International Journal of Innovation and Industrial Revolution. It's titled, Design of a Cost-Effective Loose Palm Oil Fresh Fruit Collector for Small-Scale Farmers. And we are going to explore how a brilliant, incredibly frugal piece of DIY engineering is stepping in to solve this back-breaking problem on oil palm blocks worldwide.
Right. And what's really compelling about this paper is how it highlights a classic blind spot in industrial agriculture. You know, when we think of global farming, we tend to focus on the massive machinery, the huge combine harvesters.
The big shiny stuff.
Exactly. But the real profit margins and the real hidden human toll are so often found in the tiny details that get left behind in the dirt.
So true. So let's start with those tiny details. Before we get into the engineering and the actual hardware you can build, we need to understand the stakes for you, the farmers out there. Why are we inventing a whole new mechanical tool just to pick up some fallen fruit?
Right.
What is the actual value of a loose palm oil fruit?
Well, to understand the value, we really have to look at the biology of the crop. When farmers harvest oil palm, they aren't picking individual berries. They're cutting down these massive clusters called fresh fruit bunches, or FFBs.
And those things are heavy.
Oh, incredibly heavy, sometimes weighing up to 50 pounds. So when a worker cuts one from the tree and it plummets to the ground, the sheer impact force causes the loosest individual fruits to detach from the main cluster and just scatter all over the plantation floor.
And I think a layman looking at that might think, well, you secured the 50-pound main bunch. Who cares about a few scattered pieces rolling away in the mud?
Yeah, and that is a critical error. That exact mindset can bankrupt a small farm because those loose fruits aren't just random leftovers. Biologically speaking, they detach upon impact, specifically because they are the most mature fruits on the entire cluster.
Oh, wow. So they're the best ones.
Exactly. And maturity in oil palm directly correlates to oil yield. That means those tiny scattered pieces contain the highest, most concentrated oil content of the entire harvest. Leaving them behind on the ground is literally leaving the absolute most valuable part of your crop to rot in the sun.
That's insane.
Yeah. For a small-scale farmer operating on razor-thin margins, leaving that high-yield fruit behind is just financial suicide. In fact, ignoring loose fruits can drop your overall yield by a solid 1 to 2 tons per hectare over the course of a year.
Wait, 1 to 2 tons per hectare just from the scattered bits?
Just from the scattered fruits, you absolutely have to collect them. Oh, and by the way, since we're talking about maximizing that oil yield and ensuring proper fruit maturity, just a short reminder that regular soil testing for acidity and nutrient content is essential for your blocks. And you should be incorporating leaf testing, too, if it's relevant to your fertilizer program.
Right, definitely. Always good practice. But getting back to that coin jar analogy, if you have to collect these loose fruits to survive, how are farmers traditionally getting these premium fruits off the ground right now?
Through pure, punishing manual labor. The workers are repeatedly bending, squatting, and reaching to manually gather these loose fruits, literally one at a time.
That makes me think of picking up scattered golf balls. Like, imagine someone dumps a bucket of Hundreds of heavy, oily golf balls across a really uneven, rocky, muddy field.
Yeah, that's exactly what it's like.
And you have to walk around, bend over, pick one up, put it in a basket, stand all the way back up, find the next one, and bend over again. Doing that all day, every day. It's just a
Right.
recipe for completely destroying a worker's spine.
It really is. The research paper notes that this specific task causes severe documented health issues across the industry. We're talking about chronic back pain, major spinal compression problems, long-term exoskeletal injuries.
Because of the repetitive motion.
Right. When you do a deep squat or bend at the waist hundreds of times a day, you are constantly putting asymmetrical loads on your lumbar discs. It's not just fatiguing, it's physically degenerative over time. Plus, from a purely operational standpoint, moving that way is incredibly slow. It drastically reduces a worker's daily efficiency.
So we've got a highly valuable crop and a manual harvesting method that physically destroys the human body. This raises an obvious question for me. If oil palm is such a huge, lucrative global industry, why are people still using their bare hands? Like, aren't there machines for this?
Well, they did look into that. The market actually has several tools designed for this exact purpose. But the researchers conducted a sort of benchmarking showdown of 5 existing tools to understand why they're completely failing the small-scale farmers who need them most.
Oh, I love a good benchmarking showdown. Let's run through the competitors. What's the top-of-the-line heavy hitter?
So the heavy hitter is the vacuum-based collector. This is the absolute powerhouse of the industry. It uses suction cyclone technology to pull the fruit right off the ground.
Suction cyclone technology. How on earth does that work in a muddy agricultural field?
Yeah, it sounds crazy, but it works using centrifugal force. The machine creates a powerful vortex of incoming air. And because dirt, pebbles, and heavy debris have a different mass than the palm fruits, spinning that air at high speeds forces the heavier dirt particles to the outer walls of the chamber where they just drop out.
Oh, that's clever.
Yeah, and the lighter fruits stay suspended in the center and get collected perfectly clean. It's incredibly efficient. It can collect 1,200 to 1,500 kilograms of loose fruit per day.
Wow. Okay, that sounds like the perfect solution. If it cleans the fruit and collects a ton of it, why aren't small-scale farmers using it?
2 massive barriers: gravity and economics. This machine weighs 60 kilograms. Yeah, 60 kilos. Imagine trying to drag 60 kilograms of metal through a muddy, terraced agricultural hillside. It's an immensely heavy piece of equipment. Furthermore, creating that cyclone requires fuel or electricity to run a really powerful motor, which adds a constant daily operational cost.
Right, which eats into those thin margins.
Exactly. And the upfront price. It costs a staggering 30,000 to 80,000 units in their local currency. To put that in perspective, for a subsistence farmer, that is the equivalent of asking them to buy a luxury sports car just to pick up fruit. It is totally inaccessible.
Okay, so if the space-age vacuum is too heavy and wildly expensive, it makes sense that farmers would swing in the complete opposite direction, right? Towards something totally mechanical and analog. What's the next option?
The drum-based collector. It operates entirely on friction. You push a large rolling drum covered in flexible spikes. As it rolls, it grabs the fruit and filters it into an attached basket. It covers large areas effectively and costs much less, around 600 to 900 local currency units.
Okay, a much better price tag. But if it's a giant rolling drum, I'm guessing it still has a weight issue?
You guessed it. It weighs 34 kilograms and it is incredibly bulky. For workers with smaller frames, pushing a 34-kilogram rolling drum uphill or over rocky terrain is just exhausting. It totally lacks the agility needed for uneven ground.
So the heavy machinery is out. Did they try purely mechanical sweepers, like things that are actually light and cheap?
That brings us to the rolling basket and the rake basket collectors. These are the budget options, weighing only 1 to 2 kilograms. The raked basket acts essentially like a dustpan and a broom.
But wait, if you're sweeping up oily fruits from a dirt field, aren't you just sweeping up everything else too?
That is the exact problem. The rake drags in unwanted pebbles, rocks, and sand, which contaminates the harvest and ruins the collection quality.
Right.
The rolling basket tries to solve this by using an oval wheel made of elastic wire. You push it over the fruit, the wire flexes open to let the fruit pop inside, and then snaps shut.
That actually sounds really clever. Why doesn't that work?
Because of the physics of metal elasticity. When you use elastic wire on rocky, uneven terrain day after day, the metal gets pushed past its yield strength. It undergoes plastic deformation.
Meaning it doesn't bounce back?
Exactly. It bends out of shape, it permanently deforms, and eventually it just breaks. Suddenly your tool is completely useless.
So the vacuum is a luxury car, the drum is a boulder, the rake collects rocks, and the rolling basket bends out of shape. That leaves one last tool in the benchmarking showdown.
The spike-based collector. And in many ways, this is the Goldilocks option. It hits that sweet spot of affordability, costing only 100 to 200 currency units. And the mechanism is incredibly fast.
How does it work?
It's essentially a flat plate on the end of a stick with long metal nails sticking out of the bottom. You just press it down over the loose fruits, the nails impale the fruits, and you lift them up.
Okay, wait, I have to push back here. If this thing is literally a plate covered in sharp, exposed nails that you're violently plunging into the ground, that sounds like a medieval torture device.
It really does.
Yeah, it's a massive safety hazard for the farmer. And wouldn't impaling the fruit damage the very product you're trying to sell? Why on earth did the researchers choose that specific dangerous design as their starting point to improve?
It's a vital question, and it really gets to the heart of mechanical engineering in unpredictable environments.
Hmm.
The researchers realized that the impaling mechanism is fundamentally superior for uneven, rocky, or muddy terrain.
Oh, I see.
Yeah, a spike doesn't care if the fruit is sitting in a small ditch, hidden in tall grass, or half buried in mud. It goes straight down and grabs it. The core collection mechanic is actually flawless.
So the problem wasn't picking it up.
Right, the problem wasn't the impaling, the problem was how you get the fruit off those dangerous nails once you've picked it up.
Ah, because in the original spike design, the farmer's probably pulling these heavy, oily fruits off sharp, rusty nails with their bare hands hundreds of times a day.
Which is incredibly dangerous
Yeah.
and very slow. So the researchers knew they had the best fundamental collection method. They just needed to engineer a completely new, safe ejection mechanism. And they needed to do it using frugal, accessible materials that a local farmer could afford.
I was looking at the materials list for their prototype, and one item completely threw me off. In the middle of all these complex agricultural schematics, there's a standard silicon caulking gun.
Yes.
Like the exact one sitting in my garage right now. How does a hardware store tool end up at the center of an agricultural patent?
Because it is an absolute stroke of engineering genius. A standard caulking gun is designed to push a thick liquid out of a tube, right?
Right.
It does this by ratcheting a metal rod forward incrementally every time you squeeze the trigger handle. The researchers looked at that and realized it is the perfect, pre-assembled, cheap ergonomic actuator. They didn't need to invent a new trigger system. They just repurposed one that already exists worldwide.
Okay, so let's break down the mechanics for everyone listening. How does squeezing a caulking gun handle at the top actually eject fruit off nails at the bottom?
So they took a hollow steel pole, about 127 centimeters long. At the very top, where the farmer's hand rests, they integrated the handle and trigger of the silicon caulking gun.
Okay, I can picture that.
Then, inside that hollow steel pole, running all the way down, they placed a metal concrete bar.
So when you squeeze the trigger up at the top, it ratchets that internal metal bar down the length of the hollow pole.
Precisely. Now, at the bottom of the pole is a primary iron plate with the spikes that actually impale the fruit. But sitting just behind those spikes is a secondary iron plate, which is attached to that internal metal bar.
Ah, I see where this is going.
Yeah, when the farmer squeezes the caulking gun trigger, the internal bar pushes that secondary plate forward, sliding it smoothly down the length of the nails.
It's like pushing a freeze pop out of a plastic tube. Or, pushing the plunger on a syringe. The secondary plate instantly strips all the impaled fruits off the nails and drops them safely into the basket. No hands required.
None at all. And they included a really simple spring system so that as soon as you release the trigger, the secondary plate snaps back to its starting position, exposing the nails, ready for the next plunge into the dirt.
It's so elegant. But what makes this paper a great read is that it doesn't just show us the final shiny product. It documents the messy reality of engineering. They went through 5 distinct generations of prototypes to get this right.
Oh yeah, they were out in the mud, failing and fixing it over and over.
Let's talk about that. The iterative process is where the real science happens. The first generation was actually a huge failure, right?
It was. They put far too many heavy nails on the plate.
Because you'd think more nails equals more fruit collected.
You would think so. But it created a bed of nails effect. With too many nails, the downward force was distributed too widely. The spikes wouldn't actually penetrate the hard exterior of the fruit unless the farmer practically jumped on the tool.
That defeats the whole purpose.
Exactly. Plus, it made the whole rig exhausting to lift. So for Generation 2, they drastically reduced the nail count. But then they hit a major structural wall. The joint where the long steel pole met the flat iron plate kept snapping in half.
Well, because you have a farmer repeatedly slamming this thing into the earth. Think of the physics there. It's acting like a giant lever. When you have a long pole attached to a flat plate at a 90-degree angle, every time you strike the ground, all that kinetic energy travels up the pole and creates a massive pivot point right at the weld.
Exactly. The torque just shears the metal apart.
So how did they fix it?
You're hitting on the main vulnerability there. The torque was immense. But to solve this, they didn't go out and buy expensive space-age titanium. They simply took some small L-shaped iron bars and welded them around the base of the pole, physically bracing it against the flat plate.
Oh, that's smart.
Yeah, this dispersed the kinetic energy across multiple points rather than a single weld. It gave the tool massive structural integrity.
That solves the snapping pole. But looking at Generation 4, the ejection plate itself was causing a nightmare, right?
It was. The secondary plate, the one that slides down to push the fruit off, kept sliding completely off the ends of the nails and falling into the mud.
Which is incredibly frustrating in the field.
Very. They tried using simple wire ties to create a barrier to stop it, but the sheer force of ejecting the fruit snapped the wire ties instantly. So for the fifth and final fix, they made a brilliant minimalist adjustment. They took a welding torch and dropped a tiny bead of melted metal onto the very tips of the four corner nails, creating a permanent physical stopper right on the nail itself. Exactly. The plate slides down, hits those four welded tips, ejects the fruit, and stops perfectly before falling off.
That is hardware store hacking at its absolute finest. And by keeping the parts so recognizable, a caulking gun, some hollow steel pipe, a few L brackets, it completely lowers the barrier to entry. If a weld breaks in the field, a local farmer with basic tools can repair it themselves in their own shed. They don't need to call a specialized technician from some corporate headquarters.
And that autonomy is vital for small-scale farmers. It's not truly sustainable if they can't maintain it themselves. Now, we do need to address your earlier pushback regarding the damage to the fruit.
Right, the impaling.
You asked if impaling the crop ruins the oil product, and the researchers address this biochemical concern directly.
Yeah, because quality control is everything. If you bruise an apple, it goes bad faster. What happens when you stab a palm fruit?
When you puncture the fruit, you expose its internal cellular structure to oxygen. Oxidation sets in immediately. This chemical reaction breaks down the lipids, which causes the free fatty acid levels in the fruit to spike.
And high free fatty acids are bad news.
Very bad. Once those fatty acids rise beyond a certain threshold, the oil becomes rancid and useless for industrial purposes.
So impaling them does start a ticking clock.
It does. However, the researchers conducted tests and found that the minor puncture wounds from the thin nails do not degrade the oil quality, provided one strict condition is met.
Which is?
The fruit must be transported to a processing facility within 24 hours of collection.
Ah, because the oxidation process takes time to fully spike the free fatty acids.
Precisely. And since loose fruits are incredibly valuable, they are typically rushed to the processing mill the exact same day they're collected anyway. So operationally, the puncture wound ends up being a complete non-issue.
That's a huge relief. So we have a brilliant MacGyver-style design that preserves the oil quality. But a clever drawing on a whiteboard is useless if it costs too much to build or still hurts the farmer's back. Let's look at the actual field testing. Did this thing survive the real world?
It surpassed expectations on almost every metric. Let's look at the ergonomics first. The final prototype weighs only 3.38 kilograms.
Wow.
Yeah, compare that to the 34-kilogram drum or the 60-kilogram vacuum.
3.38 kilos is incredibly light. That's, a little over 7 pounds. You can carry that with one hand.
Easily. And it stands 127 centimeters tall. This means the average farmer can operate the tool completely upright. The repetitive bending, the agonizing deep squats, the spinal compression is entirely eliminated. They literally engineered the back pain out of the job.
That is life-changing for a laborer. But how efficient is it? Does it actually pick up the fruit reliably, or are they constantly having to replunge it?
Well, they ran rigorous real-world field tests to find out. They calculated the ratio of targeted fruits successfully impaled in the dirt against the number of fruits successfully ejected into the basket by the caulking gun trigger. Under muddy, uneven conditions, the tool achieved an 83.33% average efficiency rate.
Over 80% with a purely manual 3-kilo tool. That's incredible. And did it hold up? Did the L-shaped brackets actually stop the pole from snapping?
They subjected it to intense, repetitive stress cycles in the field, repeatedly driving it into hard earth and mud. The L-shaped structural reinforcements held perfectly. It survived the full testing protocol without bending, snapping, or failing.
So what does this mean for the farmer's wallet? We talked about the economics of the 80,000 unit vacuum machine. How much does this DIY superhero cost to build?
The frugal economics are the most impressive part of the entire study. If a farmer were to go out and buy all the materials brand new, the steel pipe, the caulking gun, the iron plates, the entire prototype costs only 100 to 150 local currency units to make,
That's nothing.
right? It's already tied for the absolute cheapest tier of the market. But the researchers went a step further. They explicitly designed it to be built with recycled materials.
Because every farming community has a scrap pile somewhere.
Exactly. By sourcing scrap iron plates and leftover steel rods from local workshops or discarded machinery, the total fabrication cost drops by another 30 to 40%. It is phenomenally cheap. So for your action item tomorrow, if you're managing a farm, look around your scrap pile for an old caulking gun and some steel pipe. You can literally take this design to your local welder and have a working prototype by the afternoon.
If you are listening to this right now, this entire project is an absolute masterclass in frugal innovation. It proves that we don't always need million-dollar R&D budgets or artificial intelligence or complex robotics to solve massive industry-wide problems. Sometimes you just need a deep understanding of the user's physical pain, some recycled iron and a repurposed caulking gun.
It really forces us to redefine what we mean when we say advanced technology. For a small-scale farmer living on thin margins, advanced technology isn't a 60-kilogram vacuum that requires expensive diesel fuel. Advanced technology is a 3.38-kilogram ergonomic stick that they can build, modify, and repair themselves for the cost of a few meals. It restores both their physical health and their economic independence.
Let's summarize this journey. We started with a back-breaking labor problem where highly valuable, mature agricultural fruits were being left to rot on the ground because picking them up manually was literally destroying workers' spines. The existing machines were either insanely expensive and heavy or cheap and ineffective. So researchers took the most effective mechanical action impaling and combined it with a common silicone caulking gun to create a safe, self-ejecting system.
Right.
Through 5 grueling iterations of field testing, reinforcing welds with simple brackets, the result is a perfectly engineered, lightweight tool. It boasts an 83% efficiency rate, saves farmers from chronic pain, and can be built for pennies on the dollar using scrap metal.
It bridges the gap between mechanical efficiency and human reality perfectly. And it leaves me with this final thought for you to ponder. If a common everyday item like a silicon caulking gun can be completely repurposed to revolutionize agricultural harvesting for farmers worldwide, what other mundane, invisible tools are sitting in our garages right now, just waiting to be reimagined to solve the world's most stubborn logistical bottlenecks? We might already have the answers to some of our biggest problems. We just aren't looking at our tools creatively enough.
We just have to stop looking at the coins on the floor and start looking at the tools in our hands. Thanks for listening.